Oh my. So if this is going to set the stage for the chances of this hack working or not, I don't know. Sorry about that, everyone. So there's something wrong with either YouTube, the studio this morning, or something with Safari. I don't know. It wouldn't let me. I made changes to the stream and they wouldn't stick. And so, like, sometimes one setting would change and I'd go and change the other one. That first change would go away. Anyway, it was really frustrating. And then, doesn't matter. Hi. So as I said on the first stream, which I deleted, it's gone now, whatever, because it wasn't set up right. I'm about to try something a bit silly on the PCB that might damage the PCB, might not. And I can't really video it, so I thought I'd just stream it. You'll all get to see. So I wanted to give you an update on the Hub PCB, and then I'm going to I'll explain what I think is wrong, and I'm going to try to hack the board to be able to tell. But I don't believe it's wrong, but I don't know. That doesn't even make any sense. Okay, let's just start, shall we? And hi to everyone in chat. Sorry about that first attempt. Okay, so the PCB, apart from the USB chip, works. I've got it powered. What I did is I just soldered TX, RX, and ground, and I flashed the S3 with some code to allow me to do over-the-air updates. Right, I've left these wires on here for now, so I can always go back and stick my little programmer board on if I want to. But the board, everything on it works, and so I want to show you that, and I'll show you just quickly the bit of interface I made for it. It's only a start. Well, actually, so remember, I don't have a top-down camera, so sorry about that. But like, if I holding the board here, get it in front of my face, right? If I plug something in, see the blue LED means it detects it. It's not powering it. Powering it is something you need to decide, right? But it's got full detection of insert, so that all works. And then, what number is that? Number 2. I'll show you the interface in a second, but I can go to number 2, and I can turn the power on. You see it's green now, and you see there's power, and I can turn it off, right? And goes back to detected. I can also turn a different port on. I'm turning number 5 on, and number 5 is now on. And when it's powered but nothing's connected, it just pulses blue. And if there was an issue with power, it would be red, right? So now that you've seen that, I'll just unplug the board. I'll show you the interface, which I'm just been working on, which is here. So it's only a start. The colors are a bit, but yes, there'll be it's a full REST API. You'll be able to, via the IP address, control it remotely. Yes, you don't have to go to the web interface. But right now we have a web interface. Now let me make it a bit bigger. IP address. about 13 minutes. Temperature, humidity sensor's working. And so you can see here, that was the number 5 I turned on. It shows no device. I know the colors are a bit whatever. I need to fix that. So you can choose a port. I used to have it where you click on them and it'll turn them on and off, but I've got something else I'm doing instead. So on port 5, right, I can just turn power off. Port 1, I can turn power on. But what I'm adding is the ability to add a schedule on any port. So you'll be able to set on times and off times by groups of days, whatever you want to do. So you'll be able to, have a device turn on at 9 o'clock in the morning, stay on for 3 hours, and then turn off again if you want to. Stuff like that. And again, all of this will happen. You'll be able to access both set and reading the data via REST API. And there's also light mode and dark mode themes. Oh, that was a double click. Anyway, so as you can see, it's working, but the USB is not working. So I can't find what is wrong with the board. I can't find any discrepancy at all between revision 1 and revision 2. And revision 1 enumerates and revision 2 doesn't. 2 boards. I built another board after the stream, and it also does not enumerate at all. There's power going to it. It's stable, but the USB chip won't enumerate. And so the only thing I can think of, is the fact that I didn't put a crystal on the board, on the chip. But here's the thing. The data sheet's very clear that you can put a crystal on there if you want to, support external clock input. But if you're not using the Ethernet capability of the chip, which I am not, right? Non-Ethernet applications can support crystal-free mode, saving external crystals and capacitors. It means you don't need to put a crystal. No, the USB chip is not rotated. That would short the board, right? I'm telling you, revision 1 and revision 2 are 100% identical in every way. Anything that changed on the revision 2 is away from it. It's all on the S3 side, power control, which happens via power, nothing to do with USB. The USB side is identical. Even the placement of all the components, like I've literally taken both KiCad files and I've done a diff on them visually, and they're identical, right? So the only thing I can think of is, by fluke, the Rev 1 board is working without the crystal, but the Rev 2 board isn't working without the crystal, right? That's the only thing I can think of, because I don't know what else to do. It can't be a bad chip, because I've tried 2 boards and they both fail. And the chips are from exactly the same order and batch as the Rev 1. I mean, I can keep swapping chips on them, but I don't believe it's a chip thing. You check the fab files for Java. I've checked the fab files. The stack up was, well, I ordered the correct stack up, right? If they made a different stack up, I will never know. I can't measure their stack up, right? I could possibly, I don't know how, and I'm not even going to try, possibly try to measure the impedance on the traces, but I don't think it's worth it, because even if the impedance is wrong, it would still enumerate. The upstream trace from my USB, from my computer to the chip, is so short that there's just no chance impedance is the problem, right? I'd get flaky communication, but I'd see it enumerate. So I'm going to see if I can graft a crystal on. Going to be very, very, very difficult. I'm probably going to wreck the board trying, or at least wreck the crystal trying. The other thing it could be is the power O-ring, that it might be sensitive to that changed. P-channel FET had floating source when only... It's Wi-Fi turn off in code. Okay, wait, slow down, whatever. No, it's nothing to do with power. The power delivery for the ports is independent of anything to do with the USB. And power to the USB chip is always there. It's a 3.3 volt path. I mean, it's measured, verified, stable. Yeah, impedance. The impedance would have to be out so far. Like if the impedance would have to be 0 for it to not enumerate in some way, to not see some artifact from it. I don't know what I mean by is Wi-Fi turn off encode. You can't turn off the Wi-Fi encode. If you turn off the Wi-Fi, then you can't connect to the thing. I don't understand what you mean. The whole point of this is to be a smart hub. If you want a non-smart hub, go buy a $10 Amazon non-smart hub. But for this to be a smart hub, it needs the web interface. Or it needs the web access, the Wi-Fi access. It has to. There's no other way to control it. There are no buttons on it to turn power on and off and stuff like that, right? It all happens via an interface, whether it's API or, or the web interface manually. If it fried the USB IC, then the board wouldn't work at all. If it fried the IC is not fried. Like if the IC went down, it would probably take the power rail down, I would think. I don't think, again, it's not the chip. It's not the layout. They're identical. Rev 1 and Rev 2 are, I promise you, identical. I could probably go and reproduce the whole layered stack up thing, but they're exactly the same. Including the traces. Like, you got to remember, it doesn't matter about the upstream. So the downstream ports, they're irrelevant. My USB, wherever the port's gone, my USB cable to it, is identical in Rev 1 and Rev 2. But there's no change in the chain at all. Using the W on them. So, yeah, they're identical. There is no reason why Rev 1 would work and Rev 2 wouldn't work. The only thing I can think of is it's on the cusp of requiring the crystal or not requiring the crystal. I don't know what else it could possibly be. The datasheet is clear that it does not need the crystal. If I... big datasheet. Got to find the right... Hub USB card. Interfaces. Right. I think it was this one. Is that the W or is that the F? That's the F. Yeah. Okay. So what I've done, it's going to be difficult to do, I reckon. So there's a 25 megahertz crystal there. It's the biggest crystal I've got, and it's very little. And I have to somehow solder wires to that and load caps to it to ground, and then wire them to the 2 pins for the crystal. And I don't think I'm going to succeed. Just telling you, but I'm going to try it. We'll see what happens. I've got everything, all the other peripherals are disconnected. Austin, I'm just using it as the hub. Could it need X1, X2 handled like on other chips that are very similar? That's what I'm talking about, the crystal. But no, the datasheet explicitly says it is not required unless you're using the Ethernet portion of the chip. My Rev 1 does not have a crystal on it, and it works. So these are not 334s, 335s. Datasheet is for these are hub chips, not UART or USB chips, right? They're USB hub host chips. And they're, datasheet's very clear on it. So I'm going to try this. I'm pretty sure I'm going to fail. I might go through a few crystals. We'll see how we go. So I know that the datasheet recommends 25 megahertz crystal with 12 picofarad load caps. I do actually have some of those, but I'm going to try with a 25 megahertz crystal with a 15 picofarad load caps. Should make no difference. I should even be able to get a bad clock on it and make it work, I would think. Copy version. Those are the ones are smaller hub chips. Are they hub chips? Okay. They're the old ones, I think. There's a 339F and 339W are the ones. Oh, I don't know what those ones are. Okay, sorry, Infamy, if they are. Do you have a blank PCB that uses that XDOL? Then just populate it onto the blank PCB. I do, but it's a big PCB, and then I'd have really long traces. That's an interesting idea, but that's actually an interesting idea, Peter. I did not think of that. Let me see something. Out of curiosity, I can't remember. I think these are too big. Oh, no, they're not. Right. I could probably hook it up onto a tiny Pico, not tiny Pico, tiny S3 or tiny C6 board. Oh, wow. Very clever. Or a nano board, but I don't have any blanks. I need to find a blank. Okay, let me just go back to here for a moment so you can see me wandering around my using the hubs. No, I'm not using anything. I'm literally bypassing all hub functionality other than upstream and downstream. All power management is done off the external from the chip. So I'm setting config 0 and config 1 to their off states. Their nothing being used state. Let me think and see if I can work out where I might have some blank. Or maybe I'll just grab a busted board. Yeah, I mean, I would have chucked out all of my old prototyping boards ages ago. And that sucks. And obviously I need to put it on a board that doesn't have anything else on it. Okay. Okay, I can probably hack. Keep saying I could probably hack a board, but I don't know. You'd think I'd have one blank old PCB somewhere, wouldn't you? But I did a tidy up the other day, like the other day, 2 weeks ago. I did a tidy up, and I literally just chucked out all the old things I didn't need anymore. Now, you know that thing where you hold on to stuff forever in case you need it, and then when you finally chuck one, then you need it. Oh, is that a blank? Is that a blank? No. Okay, I can't do that. Is that a blank? No. One blank PCB. Anyone? Move crystal on the red. Or remove a... Huh? Yeah, I mean, I'm happy for you to read through it, mate. If there's anything you can spot, that'd be great. But yeah, I've on purpose because my client didn't require. Oh, hang on. Okay, I can probably use one of these. Okay, I can use one of these. my client didn't require any of that functionality, so I didn't implement any of that functionality. I don't understand, FarmTech, what you mean by remove. I don't need to remove a crystal. Remove it off what PCB? I need to add a crystal. Okay, so I've got, that's a tiny C6 board that was used for RF matching. I never bothered taking the pigtail off. I'm going to take the pigtail off and stick a crystal on there, and then, oh, Peter, that was such a clever idea. Okay, I'm going to go to microscope view. And I'm sorry, like anytime I touch the table, the microscope's going to wobble a bit. I apologize in advance, but X-pins need to be low or maybe high. No, they are supposed to be floating. And again, remember, Rev1 works. They're identical. Okay, so let's I'm going to need a bigger iron than that. Okay, I'm going to turn my iron off. I'm just going to move that out of the way. So hopefully it's in focus, or in focus enough. Hopefully you can hear me okay. I'm going to desolder the pigtail. Good. And I could probably, I'll just clean that. I could probably I can't really hot air it. I have to hot plate it, the crystal on. It's a bit janky. I'm going to give that a clean, then flux and put the crystal and load caps on. It's just IPA. Look how dirty. See that? It's just flux that was never removed. Didn't need to be. Like it was. This is only used for tuning. Okay, so turn my hot plate on. Okay, so crystal. Maybe I'll use the 12. Do I have any 12 picofarads? No. Okay, I'm just going to use the 15s. Okay, so a bit of fluxing. Hello. And just need to grab some Dean. Oh my god. Okay, no, we go to my drawer. As in my top drawer, 15 picofarad. I'm going to try to hack this onto the board with dead wire. What's called dead bug wire. But oh, Peter, you saved me from total utter embarrassment and probably wrecking the board. I owe you a beer or 10. Well, I don't even know if this will work though, right? Okay, hot plates warming up. This will not focus. I'll see if I can get this focused for you. I'm not even going to bother with the. Sorry, I'm not going to bother with the fan. I can't get it any more in focus because of the height. Oh, maybe I can lift it higher. Hang on. How's that? It's about as good as it's going to get. Sorry, with the microscope. Move it down. Maybe you can see the temp. No, not really. There we go. 88 degrees. Okay. Oh no. What am I missing, chat? It's not crystal clear. Very funny. Yeah, Farm Tech. I'm not sure which bit you're missing on this. Rev 1 and Rev 2 are identical boards. No crystals. Identical boards. For the whole USB chip circuit, etc. So, yeah. That's funny now. I can't see it. Okay, it's up to 154. There we go, snapping in place. Now I still have to keep these wires really short as possible. And that's going to be the challenge. And I need to join the grounds together, obviously. Okay, well that's enough. Turn it off. Move that out of the way so I don't stick my hand on it. I need that to cool down. So I'm going to try this on the... This is the first one I built. Oh, here we go. Now we have to... So this is the board I built on stream. The one that I haven't connected anything to, right? But I believe this board still works. I'm going to try it on this first in case I do anything that's going to wreck it. Hang on, why can't I see? Okay, you got focus. I can't really see my computer screen from where I'm sitting right now, so I can't really tell if it's in focus or not. So the pins are right here, these two, which is going to be a challenge. They're right next to each other, and there's USB trace on one side, and
Alan Madsen says looks okay.
Thank you. So I don't know what... I mean, the longer the wire between them, the more of a problem I'm going to get with it. Plus, it's going to touch other things. Okay, so let me just clean the back of this because it's got flux on it now. It's going to stick. Okay. So it's got a... The crystal pins are going to be here, these ones, right? And they'll need to connect to there. I need to check which one's plus, which one's minus on it, although it probably won't matter with this type of crystal. So I kind of need to connect them there, but that's going to be too short to work, I reckon. Plus I need a ground connection. Okay. So these are quite long, these wires, as you can see. I don't want to use the whole length, I don't think. Well, I don't, but they're hard. The shorter I make them, the harder they are to work with. So I might start by just putting 2 wires on. See if I get 2 wires on. And leaving them long to start with. See, the problem is if I get a wire on that, it's going to touch that cap. I don't know how I'm going to stop that other than trimming this. So I know you can't see everything that I'm doing with the microscope this way, but So what I'm thinking of doing is if I leave the insulation on, right, and just, if I do it like that, that'll probably work. If I do that for 2 of them, let's get the other one ready. I know some people love doing stuff like this.
Alan Madsen says we get the idea about what you are doing.
Excellent. I'm probably going to go this way. Unfortunately, the what am I doing? The iron is going to have to be on the same side. I can't have 2 hands on the right hand side. I don't know how I'm going to do this. I have to use my left hand to hold it, which is going to be a bit of a problem. I'm right-handed. I'm not terrible with my left hand, but I'm not great either. Okay, some more flux. Sorry, that's gone off. Okay, more flux. These wires conduct heat so well that when I put the iron on the other end, it's going to dislodge it off this, I think, but we'll see. Yeah. That's one. Oh, I should have done the other one first. That was stupid, because now I'm going to hit the first one. Okay, I need to move this one first, I reckon. Can you all see? Okay, you can see. Good. Get down. I feel like that's
Alan
fine.
Madsen says put some Teflon tape over that component.
Over which component? Need that shorter.
Alan Madsen says the cat.
Nah. Only live once. Come on. You're talking about from a heat point of view? Nah, I think we're okay. I don't even know if I can squeeze that in. I definitely can't squeeze it in when I've got the iron in my hand. As thin as these are, somehow squeeze that. There we go. Maybe. Yeah, I can't hold it still. Oh, let's shift. Now, are they touching? Did I solder those together? I need to see if there's continuity between them, because it looks like there might be, but it could also just be the flux bubble. So I'm just getting my DMM. Beat mode. And they are touching. Uh-oh. Yep, they are touching.
Alan Madsen says big.
So, more flux. They're really close together. I don't know what, I can't remember what pitch it is. It's either, I think it's a 0.4 millimeter pitch. Flux is wonderful, but also messy. Damn it. I don't know how I'm going to separate them. I need even thinner wire than this. I don't know what gauge wire this is, but That looks promising.
Alan Madsen says connect the meter I bit mode when you solder.
Still not. Right. Let me just check something. What if it thinks those pins are internally connected? No, they're not. Okay. I was just checking on the Rev 1 board if they're connected. No, gonna keep trying. Yeah, I don't want to wrap these around the probe, around my probes, and I'll damage the other end of them. Don't know if I can get them separated. I'll have to pull one of them off. So I have to be careful I also don't touch it to the USB pin. Okay. Got it. They're not touching now. They are not touching. It looks yuck. I'll leave it for the moment. I'm not going to bother cleaning it yet. I'm going to also need ground. Where will I connect ground to? I'll worry about ground after. Let's get these ones on first. I'm not even going to bother trying to make them short to start with. But I will need to make sure that they're separated. So I need to... I'm going to do a hot blobby trick. One of my clients taught me this. It's pretty cool. Let me show you. You know, people use like Kapton tape or something to, you know, tape down these wires so they don't move. Well, I'm going to cut a bit of hot snot.
Alex Harvey says dab of hot glue or Tapcon tape.
Yes, hot glue. You get a tiny bit of hot glue, like this. See this? Yes, it's black hot glue. Yes.
Alan Madsen says I use solder mask and iolite.
Use, I don't know what, sorry, I didn't hear that, but anyway. You use solder something. I missed it. I apologize. I'm going to, and then what you do is you melt it in place. Hold them down. There you go. Look at that. And then you clean. Got a lovely smell. Make sure you clean it all off the soldering tip. And now got blobbies holding the wires down, except did that hit the PCB enough? Yep, good. Look at that. Now, what did Alan say? Black hot glue is great. Oh, is that what you're saying? Oh, no. So I use solder mask and IR light. Okay. Yeah, it's pretty cool, isn't it, Peter? I used to use, you know, a thin strip of Kapton tape or something. And you don't use a hot glue. You can use a hot glue gun, but if it's a really small area, that can leave glue everywhere. You got to wait for the gun to warm up and all that stuff. Then you put too much glue down. This way you can really isolate what it is you want to do. Okay, so they're separated. Now I need to check which pin is in. So the one on the right is in, and I need to check on my board which one is pin 1. I cannot remember. Open. C6. Tiny C6. The one on the right. Excellent. So they line up, which is good. So I'm going to turn this around, and obviously I have to lift them up. Where to put my tweezers? Left my tweezers. Now I'm not going to know if this is going to work or not because this board might
Matt
be
says,
wrecked.
"Whoa, a Friday stream. What manner of wizardry is this?"
What? Oh, hello. It's I'm trying to dead bug a crystal onto one of these USB boards to see if the issue is crystal related. Okay, I need to snippy the length. That's a little bit too long. Work out how long though.
Alex Harvey says next week turn into watch see and make a robot from a cockroach, some wires and a tiny pico.
Nah, I actually don't like doing. I'm not a fan of doing this type of stuff. I mean, if it works, great, but just in general. Okay, now we need some Kapton. Got super thin. Can't really see that. You'll see in a moment. Or thin, narrow Kapton. Two lots. Where's my scissors? So I'll need some thick and thin, won't I? Yes, I will. I think. Where's my? Oh, okay. Okay. I have to use multiple thin strips. I'm just putting some Kapton down. Maybe if I can get it off my fingers. Oh no, I've lost the end of it. Oh my god, I can't find the end of it on the reel. Oh, got it. So thin. Two bits. One.
Alan Madsen says, "Ian, you can always get a job as a surgeon after this."
Oh my god. That is the most ridiculous thing I've ever heard. But thanks. Okay. So here we go. Fluxy, flux.
Alan Madsen says, "Have trust in you to do it."
Depends what I'm doing surgery on. What is that one?
Alan Madsen says, "PCBS."
Oh, PCBs. Oh, did I make that long enough? Shit. It's not long enough. Maybe I push it under. Okay, that might work. Might work. I need to carefully beep it. Oh, it's important thing. Make sure that this is connected to, can't see. Shit. Mic, mic scrape's in the wrong spot. Okay, it keeps moving. Good. And perhaps. Good. Okay. They beep out. So now I need to stick some Kapton over the top of that. Hold it there. You can't really hot glue on top of Kapton. Okay. And now I just need, I guess, a common ground, right? Common ground. I just covered up my ground pins. Stupido. Go there to there. So that looks good. Let's just do that. Okay. I'm going to go from this button position to this. Can't see it yet. Button position. Because they're both ground. Wait, no, that might be 3.3. Shit. That's got flux everywhere. Right. Maybe to the end of the LED. I'm really hacking this board. That's what I'm doing on this one first. Okay, I'm going to hack to the end of this LED. I'll turn over. It's a 3.3 volt LED. Oh my god, it flipped again. Whatever. I'm gonna leave it. Bitch. Sorry. I said that out loud. I'm sorry. That was annoying. Why can't it just rotate the right way? It's like an IC. Never the direction you want it to be. I'm on the wrong angle with my iron. So if you can't see, I can't control where I'm. That's not going to stay there. That's not going to stay there. Need some more solder. That's going to come off now. Oh, that might stay there. Oh, that might stay there. Okay, and you.
Alan Madsen says, can't you use the shield of the USB?
Yeah, you won't solder anything onto it. I don't think I'll get anything onto it. It's It's that metal that, you know, you solder forever and the solder doesn't stick to it. I don't know if that's actually connected electrically. I guess we'll find out if I beep it. So much beeping. Okay, so ground and yes, it is connected. So, can anyone who can tell me what stupid mistake I just made? I'm coming over here. I'm coming back. Anyone want to tell me what stupid mistake I just made? What mistake did I just make? Listen to Peter. No, I put the board and the ground wire across where I access the USB from. So when I connect the USB now, I'm likely going to rip the wire out. Oh well, here we go. So yes, I just disconnected the wire. Secondly, why do I have no power? Okay, that one does, but that's no upstream. So I've done all of this on this board, and I forgot that this board has the bad USB port upstream. I need to take it off this chip and put it on the good board. I didn't want to do it on the good board, but I'm going to have to do it on the good board. Okay. That was stupid. Transplant time. You all had nothing, and I did rip the wire off. You all had nothing better to do, right? No, not that one. That one.
Alex Hardy says it's called practice.
It's called practice, yes. If I could do it once, I can do it twice. So I need to do it on the clean board. So this is the USB that doesn't work. This one does. This one doesn't. But that's the upstream port. So that was pointless. The hot glue I need to get off. You can get it off, by the way. That's the other advantage of hot glue, is you can literally just do this and then remelt it again. There we go. So I need to disembark these wires, but they'll be in a good position to put back on again. On the next board, see? Look at that. Transplant will be easier. I have to be careful with these other wires going to the UART.
Austin's Creation says just finished my schematic, working on BOM cost and awaiting season 3 of Silo, so I'm more than happy to watch you faff about.
Faff about. Thanks. Yes, Silo season 3. But they've changed the story too much. I really enjoyed the books. But I think they're trying to be politically correct or whatever, and they've just really messed with the story. So that's a bit frustrating. Now they're joined together, and I think I'm going to need to glue it down first. The fact that I can glue it down is very cool. So I'm going to glue it down into place. If I can. It's close enough. Whoa. That smell is just awesome. In a not so good way. Okay, and I'm gonna have to pick a different ground position next time, because that was stupido. Okay, now I need to somehow separate these first. Go. Not enough room to grab it. No, not enough room to grab it. I don't know if I'm on that pin or not. I can't see if I'm on the pins. I might be, but I might not be. Let's see if they're touching each other. They're not touching each other. I just don't know if they're touching the USB or not. Or if they're even touching the crystal pins or not. I guess we'll know when we try to connect it. Okay, so I need to pick a different ground and use that. So I didn't connect up the user button on this one. I'm going to have to change what IO the user button was on. But anyway, so I've already redesigned this board. I've already got a new revision of this board, but it doesn't have the crystal on it yet, but I'm going to put the crystal on it anyway and populate it with the crystal regardless in the future for the next revision, whether it needs it or not. Okay, now let's try this one. That was much quicker. Just see on. So I should be able to, if the crystal is connected, if it works, if it's the problem, connected this. Accessory needs power. Oh. Okay, it recognized something because it's saying that it needs power. Do I have a short somewhere now? I hope not. But I might. No, the web works, so I'll go there. Okay. So if I connect this, additional power connector, yeah, this, it's saying that it doesn't, it's not giving me, I'm getting a power issue on my computer port. Hey, Technobulus. It's popping up with a, you know, like a message saying, oh, and I ripped that off. Shit. I ripped off the TX pin. It's basically saying not enough power. As soon as I connect, I get accessory needs power, unit for additional power, connect a USB port. Connect to a USB port on this Mac. So it's like it's not delivering power to it, but it's recognizing that there's something there now. So I connect this one. I'm getting the same thing, but it's enumerating. So it is enumerating now. You see that? But now I don't know if the ESP32, no, that's also getting power. Hey, Graham. But I should be seeing, so I don't know why I'm getting that message. But can I don't know if that's the USB port. Well, hang on, let's System settings, system report, USB. We should see a if I unplug it. Okay, I don't think we're seeing the USB chip enumerate. But I think we're seeing the S. Oh, did we? Or maybe we did. I think we see it enumerate and then it goes away, or does it come back? What is that? Oh, I've got no serial output on that, I don't think. Right, because I've moved the serial output to, let me see if I can flash it. Hang on. I moved it to, oh, it should be on there. I reset it. Right, so maybe that's not the S3. It's working. That must not be the S3. Quit. I wonder if it'll let me flash it. I'm using it over the air at the moment, but I could just... No, okay, that is the USB. UART, SPI, I2C, JTAG. So the S3 is not enumerating on it, but the USB chip is enumerating now. XI to ground, leaving XO floating. Granted, haven't found anything official that confirms. Sure. I mean, normally you'd float it or ground it. It says so in the data sheet. So you didn't find anything in the data sheet that said what to do with the pin? XI, the input end of the crystal also is connected to one of the end of the crystals. Yeah, we know that. See, they show it floating. So, yeah, found nothing. Okay, the USB is definitely enumerating now, but it thinks the ESP32 doesn't have enough power. Well, it's not enumerating, but it could be the way it's flashed. But I can't flash it now because I ripped the wires off. Or I can flash it via over the air. But it's already set to... Build flags already have USB CDC on boot. Yeah, their data sheet's not very clear. I need to reach out to them. It should be enumerating. But I'm definitely getting the message on my Mac that there's not enough power for the device. I know that's not true because the web's running, right? So this is flashing it over the air right now. So the chip is working. There's something about... It's just not enumerating. What if I put it in download mode? Out of curiosity. No. See, I'm getting these messages. Oh. You can't see them. It's only on one side of my screen. Like another item in a downstream port. Okay. Oh, I need power. Okay, so what's the web? Where's my web? Here. So it's in port 1. If I turn port 1 on, whoa. Oh, hang on. Oh, I'm on download mode still. I forgot to put out download mode. Okay. So port 1, power. So it shows 5 volts, 61 milliamps. My tiny Pico is going, and I can see it. There you go. There's my tiny Pico. So if I'll do that one. Well, it doesn't really matter actually. I'll go with that one. So I screen 115200. It's probably going to disappear. There you go. There's my tiny Pico connecting to what's it doing? Oh, that's my Whopper test board. But you can see it's working. There you go. It's connected, and that's the tiny Pico running. So that's going through the USB hub. So the hub is working, but the S3 is not happy. Well, it's getting power. There's no guarantee that the... So this is bizarre because yeah, it's bizarre. The hub chip is working with this crystal, but the old one was working without the crystal. And I let me... Okay. I'm just going to disconnect this, turn power off. Oops. I've changed the interface now, and now I keep forgetting what to do. But if I unplug that, oh, that's going to crap out. Unplug that, unplug that. Okay. I'm going to plug my this is the Rev 1 board. Now, even though there is... that port doesn't work. Whoa. If I plug power in, I still get both. So that now, if I knew... yeah, okay. I need to... That's what happens when you let screen die by itself without closing it. ls/dev/cu.u star. See, that is seeing the hub. You can see that there. And I'm getting the same power accessory thing needed. And then it goes away. And then see it's there. Now I've got 2. So the S3 enumerates, but then it sometimes goes away. See that? Because I wrecked this board, but this has got no crystal on it. See, it's now seeing the S3 and the hub, and then the S3 will disappear. See that? And then it'll come back. So that's the S3 dead. But this is the Rev 1 board, and it works. Works. So, and without a crystal, I just don't believe that the crystal is a solution unless there's something about the makeup of the board that is requiring the crystal. The datasheet is very vague. The datasheet says no crystals required, right? And I have all of the functionality of the chip turned off. They're just floating, exactly like the Rev 2 was. They're just floating. So the question is, if I take So if I took this, not that I necessarily want to, but it doesn't really matter at this point. I don't need the crystal. I can remove the crystal on this and I can keep working on this firmware-wise over the air stuff because it's working, right? It's just not working as a USB hub, but everything else is working. Thank you, Mr. Spring. I don't know if it'll ever ship to Tinytronics. I don't know if I don't think I'll be wholesaling these. They'll be quite expensive. I don't think there'll be a wholesale margin on them, but they'll be open source. You'll be able to make your own if you want. I'll see, but yeah, it'll be unlikely they'll be with a reseller. Can you pin which is a bunch of other? Huh? Can you and the X in on the hacked board, which is what a bunch of other hub chips from the same company wants. All good. Sorry, Infamy 4K. I don't. That isn't very good English. Can you and the X in? You mean can I ground the X in pin? Sure. I'm going to remove so motherboard. Remember, I can't use the upstream port, so there's no way of ever knowing if it works. I'm going to remove the crystal from this. We've shown that the crystal did something, right? Maybe. I'm going to remove the crystal now, and I'm going to just ground the pin and see what that does. Good idea. My coffee's cold. Who's going to bring me hot coffee? It's okay. Don't have to. Okay, let's go do this. Let's do it. This should be easier. Start with this. Actually, no, I didn't want to do that. Stupid. Damn it. Now it's melted. I'll just push it off. Let's get these off. You grab them. Okay. Come on. Come on, gluey. Get off. Thank you. And the ground. Peter, if you're listening still, if you're around, if it wasn't for you, I'd still be trying to solder 0402 caps to the back of a crystal. So thank you very much. I should put that other wire back on. Yeah. Anyway, so ground it. Okay. We want this here. Actually, no, we don't want that one. That's going to short. Where's some more wire? Grab another one. I need insulated wire. Or I'm going to short it to the top of that cap, which is going to be bad. Okay, just cutting a new bit of wire. Okay. So it's on the right. Come on, sticky. Okay, and just for now, because it's convenient. Gonna melt. Okay. So that pin is grounded. Let's try that. Okay. USB. Get that pin away though. Power. Peter should have let you try for our enjoyment. Thanks. And really? Nothing at all? Okay, that did not do anything. So, pin 1, grounded, not enumerating. And also nothing coming up power saying, yeah, no. Let me just double check it's soldered correctly. I mean, in their data sheet, they're very clear. It's left floating. God, I didn't change the camera. Sorry, just 1 second. I'm going to just flux it and just hit it again, make sure that it's got good connection. Sorry, I didn't change the camera. I'm going to make sure it's not touching the other pin.
Austin's Creation says think an email is in order either way.
Yeah, the problem is I can't demo, well, I can't easily demo it. Well, sure. I'll email them and ask him. I mean, in an ideal world, I wouldn't have butchered the first board and I could have sent it to them, right? And say, why does this work and this one doesn't work? Okay, I just reconnected it. Yeah, nothing enumerating. So, yeah, it's not a grounding of the pin. Let's try a different USB port. Yeah, no. So I'm going to add the crystal in. I should probably just do that now. So you can see here, this is the in and the out. Oh my God. Try it again. It's the in pin and the out pin. So, make some space. There's really not a lot of space. And so in the schematic, I've actually got the crystal, but I just didn't populate them. Oscillator, but not with the internal PLL when it's designed to. Doesn't that more indicate the PLL has been killed? No. How is the PLL being killed? It works on the first revision board. Doesn't work on the second revision board. Same chip batch. 2 different second revision boards. The first one I hacked on the stream. The second one build, 1 reflow, no hacks. So exclude from bill of material, exclude from board, exclude from position files. So the assumption that it could die on 2 boards, but not on this is going to be close. Okay. But not on the first board, and the first board I hacked to death as well on my first stream. So yeah, it's not. It's not a thing. Sorry. It's the impossibility level is massive. Okay, I need to move those Yeah. Sorry. I'm just going to get it routed first, and then I will worry about how I'm going to fit it, like how I'm going to position it nicely. Just one thing at a time. So I've got to be careful. I don't want... Shit, I can't have the oscillation near the USB. It's really stupid they put the crystal in point here. Like, what are they expecting? I'm going to have to rotate it and move it away. Are they expecting that... They're probably expecting I'm using a smaller, like a 2-pin crystal, maybe. Wow, KiCad, that is just the worst. Okay. Seriously. I need to ensure that I've got really good ground separation from the upstream. Okay. Not overly happy about this, but can't be worse than the dead bugging I just did. See, there should be, I need to really have ground all the way around here. To isolate it. These traces are a bit of a problem. They come through here to stay away from the USB traces, right? These aren't fast switching. Like they're a fault and a power enable. So it's a high, a low, they're not a signal. So they're probably okay, but not to go under the crystal though, but to go under the USB lines. So probably just need to really lock it. Sit still. I don't like where it is. Just need to keep them away as far as possible. And ideally, again, have ground isolating them. USB reset. Imagine if I put the USB reset line under the crystal and oscillated on that. That would be bad. Take it through the power. Yeah, I don't want it under there either. I don't want to go to 4 layers. Funky corners. I just can't do funky corners anymore. Look at it. Depressing. Okay, maybe that. So then we can now Don't like these. So the USB traces have been matched as coplanar, which means they need the ground, solid ground underneath, and they need ground on the sides. Watch this rev work without an extra. What? Oh, watch it work without. Well, it doesn't matter. It's going to be. Hopefully it'll be one of those things where if you place it, great, and if you don't place it, great. But I don't know. Okay.
Alan Madsen says remember you text for pin 14 button.
Yeah, no, I've already fixed all that. I'll show you. This is already set to go. Like I was about to make another revision without this crystal change. But I'm glad I did this test. Not that I'm convinced it's the issue specifically. So, I need grounded here. Okay, so that's pretty good isolation. Probably overkill now, but I'd rather overkill than not overkill for this. Oops. Okay. Now I just need to come back here and fix these. Okay, so we now have good ground, goodish ground patching along. This is the upstream. So as you see, coplanar, it's all I fit one here. Good. So I can't really stitch here, but we've got ground continuity all up the sides of all of the USB. I mean, not between these, but when they get broken out, as you can see, there. And a few more in. So they're all coplanar. See, all the way along. What happened here? Feel like I've lost some wires along the way. Maybe I have. They're probably fine. It's a trace here. What is that? Just going to make some tweaks because why not? Yeah, I've lost. When I rerouted, I must have never gone back and put these in. Interesting. I mean, they've still got ground on each side, right? This is just a stitching thing, right? This is not, this is not like RF stitching where I needed to specifically join the ground, like put a perimeter around the ground to hold it together. Like this is different. Like this is, so long as there is copper. So yeah, so long as there is copper on each side of the traces the whole way and a solid ground plane. Solid meaning, I mean, there's obviously wires everywhere, but no traces, nothing blocking it. No, something from there to there blocking a whole bunch of the board. Yep. So, which these all have. This extra wire stitching is not important. The return path happens under the trace, right? It happens on the ground under the trace. But when I did the impedance matching, when I worked out what my impedance I want for this particular stack up here, right, that it was set up as, it was calculated as a coplanar, which means that it needs ground underneath and ground on the sides. So as long as the ground is on the sides, which it is, we're good. The wires are just extra stitching. This is all bumpo grade, but was the revision the one where you change the USB power path, and with those Mac error messages, is there any possibility of back feeding power to the Mac? No, it's not. This is not an error thing. It's just reporting that there isn't enough power for the device, and that could be because the USB thinks it's supposed to be providing power, but it's not. The USB chip is set to, so there's these configs, config 1, right, which is also the LED thing if you're using the Ethernet, which we're not. And there's config 0. Where is config 0? Config 0. Both of these are being pulled high. They don't need a cap. They're set to 3.3. So if we go to the data sheet, yep, in a minute. So config 0. Okay, these are the chip function configuration pin 0 and the chip function configuration pin 1, right? And so if you look here, okay, so, there's also number 2, but so pin 31, it's got overall current detection, not independent, right? So if that was 0, if that was grounded, then it would require me to hook up, what page is this? 14. It would require me to hook up all of these. There's, not those. All of these, where are they? Whatever chips. For independent, I'd need to do independent power delivery and fault detection, right? There's a better example here. Using these, which I actually bought a whole bunch of. I wasn't sure if I was going to do them or not. These here, CH217, right? So power in, power out, and then it's got the flag for overcurrent sensing and stuff. Now, I'm already doing all of that stuff with my load switches. I don't need that because I'm powering separately. I want to be able to, so if I use power via this chip, then I don't get individual power control. I can't say turn port 3 on but leave all the rest off. I either give them all power or I take all the power away, which is not what I want because there's only one power enable pin. Let me go back to 14. 14 here, right. So I'm using overall current detection, and I'm setting the current detection, yeah, here, high. So you can see here it's a active low. So if overcurrent is triggered, it gets pulled low. I'm telling it it's always high. So it never thinks there's an overcurrent situation, right? So that takes care of that. And also, well, I should actually show you when they're all set to 1. What have I set config to? Now let me just find config to. What pin did it say it was? 46. 46. I've also set high config, right? So they're all 3 are set high, which is this one. Should have shown it here. So overall detection, yes, that's what we want, and I've taken care of that. It's not independent. Overall power control, yes, okay, not independent. Okay, independent meaning on the chip, which as I said, I can't do. And then USB to JTAG, unfortunately, yes, and yes. They are turned on by default. There's really no way to turn them off unless I use this mode. And this mode here requires the independent overcurrent, which is an extra 6, 12, 18, 24 components, but I'm already using the load switch, right? So that's okay that it's got those, but upstream port exchange function, we don't use, and there's I don't know what the extension isolation is. They're turned off, right? And then if you look here, config 1 and 2, when they're both on, there's that's for the F. Sorry. Oh, thank God. Oh my God, I'm going, what? I've turned Ethernet on. That's the F chip. Okay, that's the W chip. So that's what mode I'm on, right? They're all set to high. And I'm assuming like that's it, right? I'm not using this. But if you might have noticed when the port was plugged in before, if I plug this one back in, and if I go here, you see this USB JTAG serial debug unit. It's got blah, 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 and it hang on. Right, that's the S3 it's picking up. See that? This is a Rev 1 board. It finds the S3 and then it'll disconnect from the S3. See? And then it finds the S3 and it disconnects from the S3. That's the S3. But why is it not showing me? Oh, they didn't put the other power. Sorry, 1 second. I think that's why. Okay, here. You can see it finds a UART plus SPI plus I2C plus JTAG USB device. That is the hub. They're the extra things that are ticked, right? UART, SPI, I2C, JTAG. UART, SPI, I2C, JTAG. It's finding those things, right? So the configuration, I believe, is correct. The upstream port exchange function, I believe that's the Ethernet. When upstream switching function is enabled, it continues to use as a switching control pin. Yeah, right. Are you using Ethernet? No, I'm not using the USB, the Ethernet. Right? It's off. They're off. So, yeah. So configuration-wise, I believe this is correct. And everything else is as per default in the datasheet. So does this, what I didn't check is, Does this pass DRC? Have I got a via too close somewhere? Yes, I do. Which one? That one. Okay. I figured I did. Okay, try that again. Okay. So we passed DRC. I've now got, just to show you, I've actually changed quite a bit of I/O. So this is now I/O 48, the user button. And I moved a few things around. I actually had the VBus sense pin on a strapping pin, which was stupid. I don't know why I did it. I wasn't thinking. But these were on a strapping pin. They're now not. So USB 3, so I/O 3 strapping pin is now clear. 45 and 46 are now clear. I'm not using them anymore. And I had a pull up on 46, which meant I couldn't go into download mode. Stupid, I know. What can I tell you? So I should actually mark these as not connected. Should actually mark these as do not use. Actually, left justified. So the thing is, you can use them, but you can't put pull-ups on them. You can't influence them, right? And that's the problem. I'm going to do the same here. Because pretty much every single thing that connects to these now requires pull-ups. So all of these pins here, right, they've all got pull-ups on them. And then the power control for the sense, right, for is there a fault and stuff, have pull-downs on them. So you can't just stick pull-ups and pull-downs everywhere on strapping pins that have a default state when it boots. And I don't even know what the hell I was thinking at the time. But yeah, I picked the wrong pins, but they're all good now. I've gone through them all, double-checked everything's fine, but yeah. So yeah, I think the board's good. I'd like to look if I can get this going. If I can ever design.
Nick says, are you still using those USB connectors you had problems with the other day?
Well, I don't have a replacement. And my second board I built, all the ports worked fine first time, all of them. So this one here that has the that I put the crystal on the second time that had this stuff, right? Every single one of these USB ports works. Didn't require any rework. I think it's just a matter of how they reflow the first time. And for anyone that wants to bring up again that it's because I was hot plating them, the pegs do not go through the bottom. Hang on. Actually, I can show you on here. Let me go to my Mickey scope. Let me go to the Mickey scope and show you the pegs. Oh God, is that in focus enough? The pegs do not go through. They are inside. Okay, they don't go through the PCB. So it's sitting on the hot plate pushing the USB port up issue. Was not in any way. It's the exact reason why I went with a 1.6 millimeter PCB. And I'd already had these USB connectors here before I ordered my first Rev PCBs, and I measured the peg legs because I don't always trust the data sheet. So the issue is not that. What I believe the issue is that on this board here, this is the third USB I've tried putting here. And what I found on this one, which was interesting, was the, let me grab a USB connector. And I get this on my horizontal ones as well, by the way. One in every few hundred. And I go through a lot of USB connectors, right? That I get these, and you see the plastic peg legs here? Oh, no, you can't see it here. These plastic peg legs, right? Sometimes they come and they're broken. They're broken and it's off to the side. It looks like, let me see if I can break one of these to match. Okay, I broke it right off, but it's kind of half broken like this. Can you see that? And what happens is it doesn't fall off. It's still connected. Did that one fall off? No. But what happens is when it tries to place it, it doesn't go into the hole, which means the USB sits proud. And I get that sometimes on my boards. Like I'll have a board, right, goes through manufacturing, and I don't notice the USB sitting up. Like when I'm inspecting it on my line, I'm looking down on it. So you can't always see the USB is up. But what happens is, let's focus, is it sits up and none of these pins on one side are connected because there's a gap underneath. And I just get this, you know, like, as I said, I go through a lot of USB connectors, and just every once in a while, the USB is sitting high. And when I look underneath, one of these plastic things is in, and the other one I can see isn't there. And if I look from the side, it's broken, and it's not in the hole. It's just what happens with these things, unfortunately, and I don't really have a solution for it. But this board, every USB worked first time, no problems. They all sat flush, and so you can see on the back, no rework, no flux, no solder, nothing. They all just worked, and I've tested every port. I put a tiny pico in every port, and I've read the serial out of them, so every pin's connected. I've tried, what do you call it, both directions, USB on both directions, and they're all good. Can I make the hole slightly larger? So the problem with the holes, should I just rip the other wires off? I'm now down to
Dr. Nick says,
none.
can you design a large oval shaped cutout?
Large oval shape. A large oval shaped cutout? No. And you can't do that. Okay, so think about what you're suggesting. You're telling me to take the alignment pins, which are there specifically to align the pins on the pads, and make the holes bigger so I lose the alignment. Those things are there for exact purpose, right? You can't use the peg legs to align the USB, right? The peg legs are really narrow, and no one manufactures slots narrow unless you pay humongous money for USB, for your PCBs, right? So there is massive play in the slots on purpose because they're designed to have solder go in to the holes, into the slots, right? If those slots are really tight, solder doesn't go in, and the pegs don't go through, so solder has to go in, yeah? So the only thing you're left with for alignment are those plastic pins. So if you make the holes so big, firstly, you can't make them so big because the holes are pretty much already borderline DRC error with where the pads are, right? But you just lose alignment. You end up with USB ports that don't work sometimes because they're not on the pins properly. A lot of the time, US vehicles had oval holes on body panels so they could fit them on the production line. Sure, but we're talking about, really tiny. Where's the board? Blank board. We're talking about really tiny slots, guys. Really, really tiny. Anyway, it doesn't matter. My slots are 0.4 millimeters wide already, and that's it. And that's got a lot of slop, a lot of play. Too much play. Anyway, had a port that had them but wasn't listed in the data sheet. I've never seen a USB port that doesn't have the plastic alignment pins. I would never use one. So you know which ones don't? The original USB, the micro B USBs I used to use, the very original ones, they were surface mount only. I'm not sure if you remember, if any of you still remember or hear when I was prototyping the original Tiny Pico, before I even thought of doing a crowdfunding campaign. I was using surface mount USB connectors, and they did not have alignment pins, and they were terrible. I had to fix them all the time. So I've never seen a USB-C connector of any description that didn't have alignment pins. I just wish they weren't plastic. I mean, I don't know what else I'd make them in, but I just wish they were, or a plastic that was more durable, that couldn't break that easily. Because I can't tell on a USB connector in my tape on a feeder if there's a broken guide pin or not until I've placed it. Like, you know what I mean? Like, I can't take all the USBs out of the tape, have a look and put them all back in, and then suddenly reseal the cover tape. So, and if you consider that at a guesstimate, I've gone through at least 130,000 USB connectors. I've had my fair share of ones with busted pins, and it's infuriating. But when it happens, I normally catch it before it goes into reflow. I normally spot that it's sitting proud, and I'll try to push it down, and it can't push down, and I know that there's a broken plastic leg, and I on the line I take it off and I put a new USB on before it goes into reflow, because fixing it after, it's a real pain. You're talking about a lot of flux and a lot of heating up that USB port to get it off and stuff. Well, now still don't know why it seems to require the crystal now. No, we don't. See, here's the thing. I still don't have a reason why Rev 1 works and Rev 2 doesn't. I don't know what it is. And putting the crystal on, I should have just done that to start with. Sure. And it's here now. But I'm not convinced that that's the problem. So I'm not sure what to do. Like, I'm going to get these made. I fixed the power here. So I'm not sure about these 5.1K resistors on the upstream port, or even on these. I'm going to have to double check those again. I believe they just select 5 volts. Why can I not deselect that? Anyway, did you calculate the capacitance of the 2 caps around the crystal? Nah, it doesn't need to be that accurate. No, I mean, these crystals that I'm putting down now are 12 picofarad. They require 12 picofarad caps. Actually, no, the ones I'm going to put down are 15. I should change that. Make sure I change that. So these are 15. And this crystal is where did I put it? I need to find. Let me go to JLC PCB. Hang on. As far as I can tell, I don't think it has disabled Ethernet. I think it's still trying to run Ethernet and thus needs the crystal where the F variant pin has a pin to disable it. Do you think? Like it doesn't show up stating that there's a USB to Ethernet PHY available. You could be right. But I don't know. The data sheet isn't really that good. Like, isn't clear enough. CSC. LCSC, and the part number is C2149220. I bought these a while ago. 10 in stock. Well, that's bloody useless. Just put this in here. I need to actually populate all of the parts on this properly. Description. Okay. And need to update them on here. 15. I'm using this crystal with 15s because I have 15s on my production line, and I don't have 12s on my production line. And this way, I don't have to add a new capacitor on the line. Yeah, the data sheet's not great. I'm going to email them and get some clarification. Yeah, but look, it's in here now. Ooh, I should probably join those. Not that it matters, but just for continuity. Look, I might email them and also send my, I mean, the schematic's a bit of a mess right now, but send the schematic through at least this part. I should get rid of the not required, huh? Because it is required. Send them the schematic and say to them, what's the deal? Why can't I, get this working? His computer didn't boot for an hour. Maybe it was telling you to go do some work. I don't know. Okay, anyway, we have a plan. Let's check it one more time. I'll probably send these off to get made today, but we're not going to be back in time for next Wednesday. Probably want to change the date now. 3rd, Silo Season 3 Day. Yeah. Okay. Build some Gerbers. Plot. Generate drill files. Okay. Done. Wow. It's just one of those things. I don't know. I can't explain. I can't explain why, which makes me worried that if I get a new set of boards made, even with the crystal, I'm still going to have another problem. Like, I don't know why it thinks there's not enough current for the S3, and the S3 is not getting current. It's not getting power from that. It's getting power from the LDO, and unless the USB chip's pulling a lot of current, but I don't think it is. Did you see anything in the data sheet, Austin, about current draw on the chip? You can't, well, Austin seems to think you can't actually turn the Ethernet off, but I think that's what this upstream port exchange is. When the upstream port is at the same speed as the downstream port, when the upstream port is the downstream port connects port to TT. Oh, okay, maybe it's 9 upstream port supports. Let's just talking about the upstream port. Data sheet does not even have a mention of hardware erratas. You're telling me they got them perfect. Yeah. As I said, are you guys looking at the latest data sheet? Is it 1.2? Have they got a new one? I mean, I downloaded this, I don't know, 2 months ago. Maybe there's an update. So non-Ethernet app can support crystal-free mode. See, they're very clear. Non, but how? And is that? So they're talking about 2 features here. 7-port USB hub. They're talking about the W, right? Because the F is a 4-port hub. 7-port USB hub provides 7 USB 2 downstream, compatible with 1.2 protocol, right? Blah, blah, blah. Support for gang, overall link, blah, blah, blah. High-speed MPT, self-developed dedicated USB PHY, low-power consumption technology, supporting self-power supply or bus power supply. Functions such as self-power supply bus can be configured through I/O.
Says there is a 1.3 version.
Oh, okay. I'll have a look in a sec. Thank you. But they're very clear. Non-Ethernet applications can support crystal-free mode, saving external crystals and capacitors. USB to Ethernet and USB high-speed card reader. Built-in, self-developed. So does it... Well, let me just... Dropped in Discord. Thank you. Let me... Okay. Close that one. And downloads. Okay. 1.3. This is just a preview on a Mac. It's not a PDF reader. It's the preview app. You can preview anything. Ethernet. Probably has no difference. Pub and rapid function thing. USB is that function. 3.9 chip integrated is that. Mac controller. Oh, for memory, I think maybe from memory, Ethernet doesn't, I could be wrong, doesn't power up if you haven't connected the Ethernet pins. Like the peripheral needs the adjacent hardware connected to it for it to actually be enabled. But I can't remember where I got that assumption from. Bruce, no, it only mentions that on the F chip, not on the W chip. So here, this is for the W, the 4-port chip. The only explicit thing I see for Ethernet Table 5, which is the F chip. That's right. But if you look at here, so this is what I base it on. Here's the W, which has got, oh, that's the USB with the USB NIC, right? To multiple USB interfaces. Sorry, I need to go. There's stuff everywhere on this. I thought there was another diagram. Okay, so looking in here, where are the Ethernet pins? So these MD differential transmitter for 10 base per Ethernet. So it's pins 1, 2, 4, and 5. It's 1, 2, 4, and 5, which I have. Nope. Pins 1, 2, 4, and 5. I have not connected. Yeah, it's pretty crazy. They've got 100 gigabit Ethernet PHY inside it. Like it's and the Ethernet chip's great. I'm using that on the cat door project. They're 339D. 390D. Oh my god. Whatever it is, I can't remember the number. I mean, their Ethernet stuff is really good. Yeah, like these are just not connected. So correction on something I said earlier. You can do individual power control from this chip to the different ports and have individual overcurrent. What you can't do, is provide them direct individual power. All the power has to go through the chip. So each port's power has to get wired directly to the chip, and then you can turn on and off each port via an I/O. But it means on 6 ports with, lots of current, you're pushing all of that through this chip. And that's a configuration I can't do on that client board. Right, on the client board, every port has power coming from a 20-volt source through a pretty hefty buck. And that's fixed hardware that can't be negotiated. So I couldn't do the power stuff with this. And remember, my original idea with this was to build a board that matched the client spec. I probably could rethink it to do power control from here, but then I have to do overcurrent through here as well, and the overcurrent has to go through a whole bunch of other chips, which it's 4 chips, four parts per port. Anyway, yeah, I don't know what else. I don't know what it is. I wish I did, but I don't. And it's been 2 hours, and so I don't know if I can call this partial success or not. We got some life with the crystal. So I'm hoping on a new board with the crystal, we'll be able to push forward with this finally. But as I mentioned before, all the rest of the hardware on this is working, is validated. The 2 INAs are working great. As I mentioned here, well, as I showed before, but I'll show one more time. if I plug something into it, so 90 pico in USB 4, right? So as soon as I plugged it in, you see that? It showed me something's there. And if I enable the power, see, it shows current. So that went up to 154 while I was connecting to the internet. Connecting, and then see it pull back down, just sitting there idle. Verified, validated, what's the difference? It's working, right? The temperature sensor is working, the onboard temperature sensor. Web's working. I mean, I guess under full load, the hub could use 150 milliamps, but you haven't stressed it yet. No, but I need 550 for the S3 to enable the Wi-Fi, right? Just while it calibrates. Like there might be a headroom issue. I don't know. Maybe I should put a second USB, a second 3.3 volt LDO on there, one for the chip and one for the S3. I don't know. Yeah. But it's working. I mean, so the INAs all work. The RGB LEDs all work. The temperature sensor works. I've got no real way of activating the current limit on it unless I do something stupid like short my tiny pico, I guess. I'm not going to do that right now, but I'm assuming that's going to work. Well, the load switch works. I can turn it on and off. How do you negotiate power with the upstream port? USB. The upstream port is just a USB port going to my computer, so it's got like anything. It's got 5.1K resistors on it. Yep. So it's yeah. So it, but I don't know why I was getting that power thing. It was like it was thinking that so where's power control 1? Overcurrent 1. Ah, really, Peter? Is that really a thing? Okay, well, it validates my requirements, and I'm the user right now, aren't I? The datasheet uses a CH211 PD. Well, I don't need PD. I'm providing it 5 volts. So, but let's have a look. CH211. Right, that's but I'm not using, like, that's if I'm hooking up PD, right? But I don't, it's a Type C PD high voltage interface chip with built-in high voltage switch and booster module together. With the chip, it can realize the high voltage PD function. Detail function can be viewed the corresponding chip manual. So the user doesn't need to carry out any development. PD supports USB 2.3 protocol maximum external output. Supports USB Type C. Yeah, like I'm not powering devices through Yeah, I know there's an open source one out there. I'm not powering the devices through the 339W, so I don't need that power. They're all being powered independently. An open source one in Chinese. Translate to English. How do I do? Rubber 4-way current detection, independent USB. Hub fully open source. Right, it's using. That's not using a W though, is it? Oh, it says W. It says 4-way. Oh, 4-way current detection. The first version, the downstream report made a mistake once. Only the ground was connected to the sampling resistor, and the shell was directly grounded. Sure. Yeah, I've seen this project. I've seen it before. I haven't gone through his schematic really. I mean, he's doing things a bit different from me. But can you even open his schematic diagram? So where's his upstream? So his power control, right, he's left power control floating. Power control floating, and the configuration, he's controlling that where? I can't see where he's controlling the, oh, here. Right, he's just pulling them all up. Do 1K resistors, Jesus. Well, it's not more validation than it's needed. But sure. I mean, I don't know what else he's doing with his thing, right? Jamal, yeah, sure, I understand. But I'm not powering, as I said, I'm not powering it through the chip. I'm not powering it through the chip, but they do, I mean, everything goes through this, you know, wherever the power's coming, there's ample power coming in, but what am I doing with my power control? So I've just got them floating as well. Power CC, power. I'll have a look through his schematic later just to make sure, to have a look if there's anything else. But yeah, I'm hopeful I've covered everything now. I just don't know. I don't know. But I had not planned on a 2.5-hour stream today. I planned on quickly checking the crystal and then getting back to work. Well, it's now 11 o'clock and I've done no other work. So, naughty Sion needs to get to work now. Well, I'm at work. Needs to continue work. Something like that. Thank you all for watching. I have no idea how many of you there are, actually. Hadn't looked at the stats at all during the stream, but yeah, thanks for joining and helping out and your thoughts and calling out stuff. Big thank you to Peter for the crystals suggestion on a separate board. Woo! And to Austin for, and all of you, I guess many of you also did, trawling through the data sheet to see if there's anything I'd missed or whatever. So I will sit on this design for the rest of the day, I guess, and I've got other stuff to do, but I'll go through the schematic one more time and tonight, and if I can't find anything obvious, I'll just go and get these boards fabbed so we can try it. Yeah. Okay, folks, have a lovely weekend, and I will hopefully see you all again on the stream next week. Bye. Thank you. Yeah, bad data sheet. Okay, bye.